Welcome to Summarize Science. Have you ever wondered what an AI is actually thinking when it generates text? While their internal mechanics are incredibly complex, researchers are now visualizing these processes, uncovering the hidden geometry inside the minds of large language models. In a new study, researchers created a pipeline to run models like GPT-2 and LLaMa on text, capturing snapshots of their internal states at many different points. They then used powerful dimensionality reduction techniques to turn this high-dimensional data into images we can understand. One of the first things they noticed is that the very first token in a sentence gets special treatment. Its internal representation has a much higher norm or mathematical magnitude than any other token. It's like the AI is internally flagging the start of the sequence with extra importance. But their most significant finding came from looking at the two main components of a transformer block, the attention and the MLP layers. When they plotted the outputs from these two parts, they saw something that had never been documented before. The outputs from the attention module, shown in blue, and the MLP module, in red, consistently occupy completely separate regions in the latent space. This clear geometric separation is a stunning find. It strongly suggests that these two components have very different and specialized jobs in how the model processes information. They're like two different teams, working on the same problem from their own distinct spaces. The researchers also visualized how these models keep track of word order. For GPT-2, the positional information forms a beautiful and complex helix or spiral shape in high-dimensional space. Each point on this intricate shape corresponds to a specific position in the sentence. This demonstrates the high dimensionality of the geometric pattern the model learns. The newer LLaMa model, which uses a different method for positional encoding, shows a different pattern. Its geometry starts as a long tail for the initial words and then condenses into a dense cloud for the rest of the sequence. This shows how different AI architectures can evolve different internal strategies to solve the same problem. Finally, in a fun experiment, they fed an AI the same token repeated 2,000 times. They found that the model's internal state eventually converges or settles into a stable pattern. The visualization shows this journey as the representations for the repeating token find their final, stable location. So, what's the big takeaway from all these fascinating pictures? This research provides a visual map of the inner world of LLMs, showing that there are clear, organized geometric patterns inside these supposed black boxes. We saw that models emphasize the first word, that their main components work in geometrically separate spaces, and that they form elegant shapes to track word order. By turning abstract mathematics into concrete visualizations, we can better understand how these AIs work. This is a crucial step towards building more transparent, reliable, and safer artificial intelligence in the future.